here's a series of statements that I'd like you to try to prove. Okay? And by proof, I mean give me the best reasons you can why each of these statements has to be true. You might not nail it, but at least think about it and make the attempt. Okay, so first statement, any length factor 1 over 2 to the n is constructible. What I mean by that, I mean given any length, distance between any two lines, and any value of n, where n is an integer, and that's implicit. We're going to, n is always an integer, and m is always an integer. And that would have an m down here. So I'm going to maybe write up here, n and m are integers greater than 0. In other words, counting numbers. Okay. So that's always possible. So why is that? If you've done the geometric constructions you've been asked to do, or understand the whole process of geometric construction, and especially bisecting a distance, you should be able to get that. Okay? Then, 1 over 2 to the n can be as small as we wish. Okay? If we want 1 over 2 to the n to be less than 1 trillionth, can we make it so? If we want it to be less than 1 divided by a Google, can we make it so? So think about why that should be true. Then it follows that m times 1 over 2 to the n is constructible. By is constructible, that means we can at least theoretically construct it with compass and straight edge. We can take any line and then divide it, or find a line of length whose length is m times 1 over 2 to the n times the length of the original. Now, as an example, of course, we see that we can easily find the length, construct a line which is 3 times 1 over 2 to the second, which is 3 times 1 over 4, 3/4 the length of a given line. Okay, so 3/4 is the form m times 1 over 2 to the n, where m equals 3 and n equals 2. Okay, 2/3 is not of this form, is it? M, you could use 2, but 3 is not of the form 2 to the n. Then, and this is not an exact mathematical statement, but you can understand what it means. Any line, and I mean by any line, I mean any infinite line. Of course, we don't have time to chop up an infinite line into anything because we'd have to be at it forever. But theoretically, the line could be chopped up, or any segment of that line that we might wish to consider could be chopped up in some finite time in intervals of length 1 over 2 to the n times L. We consider L to be the length of whatever is given. We don't even have to have a number for it. It's just some length. And we divide it into intervals whose length is 1 over 2 to the n times that length. So why should that be true? Why should we be able to make this statement? Now that means we got this infinite line, or any segment as big as we wish of an infinite line, that we can chop up into these intervals. Okay. Then, no matter what factor we wish, no matter by what factor we wish to change length, and by change length I mean implicitly the length of a given line segment, we can come as close as we wish by using some factor of the form m over 2 to the n. Okay, so if we want to come within a billionth of a unit of that length, we should be able to do it if we choose a sufficiently large number n and the right number m. It can always be done. So, leave that for you to think about. I'll discuss that in the next video.